Hello all, welcome to my YouTube channel Know About Embedded Systems. So in today's video we are going to understand the basic features of STM32 microcontroller. So basically STM32 microcontroller is one of the standard and very high-end microcontroller. Most of the industrial applications are using this STM32 microcontrollers. In this video we will understand in detail the features, what are the different features of STM32 microcontroller, and we will understand in this microcontroller. So before starting the video, so if you're a new here to my channel, kindly subscribe my YouTube channel, click on bell icon and share this videos to your friends and colleagues. Let us start the video. STM32. So guys, as I told you already, STM32 microcontroller is one of the very high-end microcontroller, and most of the industrial applications we are going to use the STM32 microcontroller. So under STM32 there are different series of microcontroller. More than 100 plus different series are available under this STM32. So currently what are you seeing on the screen? So I'm going to explain you what are the different features of STM32 this series, STM32F411 series. This is also one of the industry standard microcontroller, but so there are different microcontrollers available in STM32. So now if you see this, you know that STM32 microcontroller is basically a 32-bit microcontroller. So these are all the important features you can see here. So if you see the features one by one, the first important point I want to explain here is the core feature you see here. So STM32 microcontroller uses ARM Cortex-M4 core ARM Cortex-M4 processor architecture it uses inside, and up to 100 megahertz, the frequency operating frequency up to 100 megahertz, and execution speed you can see here up to 125 mega instruction per second. Okay, that's the first and foremost thing is STM32 F4 microcontroller uses ARM Cortex-M4 architecture, and it uses 100 megahertz frequency. That's the first point. And the second point, when it comes to the memory, so it is having 512 kilobyte of flash memory and 128 kilobyte of SRAM. 512 kilobyte of flash and 128 kilobyte of SRAM we have in this microcontroller. Then when it comes to the clock here, you can see here the clock operating voltage would be around 1.7 to 3.6 volt. Your microcontroller will operate between 1.7 to 3.6 volt, and then we have different resets available in this microcontroller. One is called power on reset and one is called power down reset, then programmable voltage detection and brownout reset. So POR stands for power on reset, PDR stands for power down reset, PVD stands for programmable voltage detection, and then BOR stands for brownout reset. These are all the different resets available inside your microcontroller. And you will have a crystal oscillator. The external crystal oscillator you can connect from 4 megahertz to 26 megahertz to this microcontroller, and internally we have RC oscillator which is up to 16 megahertz. It is possible to generate from the RC oscillator. And then we have RTC inside. For this RTC, dedicated clock available, that is 32 kilohertz of oscillator is available for RTC. So this is all about the clock which is available, clock system which is available inside the microcontroller. When it comes to peripheral part, you can see here ADC. This point talks about ADC. In this microcontroller we have 12-bit ADC here. So we have 12-bit ADC, and we have up to 16 channels. So we have 12-bit ADC and 16 channels we have, and also you can see here 2.4 mega samples per second. So that means 2.4 mega samples it is able to generate in a 1 second. So this is a very good thing about this microcontroller. Then when it comes to DMA stands for direct memory access. So we have 16 stream DMA we have with a different FIFO, which is used to transmit data from one peripheral to other peripheral. Then we have timers. There are totally 11 timers available here in this microcontroller, and out of that 11 timers, some timers are 16-bit and some timers maybe 9 timers are 16-bit, and there are 2 timers of 32-bit. And these timers are able to operate in a different operating modes you can see here. So these timers are able to operate in IC. IC stands for input capture, then OC stands for output capture, and then PWM. So all possible ways or all possible modes your timers are able to operate, and the timer operating speed is up to 100 megahertz. Okay, along with that, we have a Watchdog timer as well here. In the timer section, you can see here there are two Watchdog timers are there. One is called window Watchdog timer and independent Watchdog timer. So we have two Watchdog timer, you can see here. So we have two Watchdog timer. One is a independent Watchdog timer and one is window Watchdog timer. And also we have system timer as well. That's called as SysTick timer. So this is all about the timers section in this microcontroller. Then as usual, most of the microcontroller will support a debug mode with a serial wire interface. That is what you're seeing here. Most of ARM Cortex based microcontrollers will support a single wire or a serial wire debugger. Even this microcontroller also will support this SWD or with a JTAG. Coming to the GPIO section, you can see here there are totally 81 GPIO pins are available and all are operating at 100 megahertz. 81 GPIO pins are available. Almost all GPIO pins are able to operate at 100 megahertz. Then coming to the communication interfaces. So there are totally 13 different communication interfaces are available. So you can see the first point he's talking about I2C here. So there are 3 I2C circuits are there. There are 3 UARTs are there. And then we have a SPI, 5 SPI channels are SPI protocol supports are then we have SDIO, that's secure digital input output interfacing is also there. Then we have USB. So this section, whatever you are seeing, this is all about your communication interfaces. That includes I2C, UART, SPI, and our USB as well. So then we have a CRC unit. CRC stands for cyclic redundancy check. This CRC unit is used to provide the checksum before transmission and also in order to verify validity or integrity of the data. So this I'll explain in detail later in upcoming videos. Okay. So this is all about just features of your STM32 microcontroller. In upcoming videos, I'll be explaining what is the architecture, how the architecture is defined for this microcontroller, and later on we will develop the program for different peripherals. So I hope this video is an informative video. If you feel this video is an informative video, please click on like button, share this video and subscribe to my YouTube channel.